Okay, so these are a couple of problems that we need to discuss that are not on your notes, but are some things that you're going to see. More than likely something you would see in an assessment. So it says you go to an amusement park that has 16 roller coasters. You're planning on riding at least 13 of those. Now, first off, it says at least 13. That means you plan on riding 13, 14, 15, or 16 of the roller coasters. So it says how many different combinations can you make? So remember, combinations means the order doesn't matter. So we want to make sure that we're talking about just groups of the roller coasters. So you have 4 different situations here. So you can do 13. So that would be 16 combination of 13. Or you can ride 14. So this is going to be a plus in between these two. So you're going to do 16 combination of 14, or you can ride 15. So that's 16 combination of 15, or you can ride all 16. So that's going to be 16 combination of 16. So what you want to do is each of those 4 combinations, and then you will get your final answer by adding those together. So your answer here, if you do each of these different combinations and add them together, your total answer would be 697 different ways, combinations to ride those 16 roller coasters, at least 13 of them. So when you're talking about our at least or an at most, you're going to be doing an or situation. We've done them before, combinations before, where we multiplied them together, where we did like the sophomores and the juniors, or the juniors and the seniors in the class student council thing, the debate club, something like that. I can't remember. Anyway, so these are going to be an or when it's talking about at least 13, because it's 13 or 14 or 15 or 16. Now the other type of problem that we were looking at is when you're talking about arranging letters from words. Now, if we're using all of the letters, these are permutations because it's an arrangement of these letters. And if you're going to use all the letters, then that would just be your factorial. Okay, so there are 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a 9 factorial. Now, the problem is we have repeating letters here with the A. It looks like that's the only one. So we have a repeating letter of A. So it really doesn't matter which way the A goes, because you can't really tell the difference between the two. So what we're going to do is we're going to divide out by the number of letters that repeat. So each factorial of each type of letter that repeats. So in this case, it's just an A, and there are 2 of them. So we're going to divide 9 factorial by 2 factorial. So when you do 9 factorial by 2 factorial, okay, you get 181,440 different arrangements of those letters, So you're just going to go into your calculator, do 9 factorial. Now remember, the factorial program is under the math key. Go over to the probability menu, and it's number 4. You'll see the exclamation point. Okay, so now down here we have multiple letters that repeat. So for S, we have 1, 2, 3, 4 S's. So we're going to have a 4 factorial for the S's. We have 1, 2, 3, 4 I's. So we're going to have another 4 factorial for the I's. And then we have 2 P's. So we have P that repeats twice. Now there are 11 total letters in Mississippi. So we have 11 factorial on the top. And then down here we're going to put in parentheses 4 factorial, 4 factorial, 2 factorial. So we're going to multiply those together and divide all of that into the 11 factorial. And that gives us 34,650 different ways to arrange the word Mississippi. Now, one more problem down here, the word alphabet. So again, similar to algebraic, there's only 2 of the same letter. That would be an A. So you're dividing by 2 factorial. and there are a total of 8 letters that you're using. So alphabet has 8 letters in it, and that's going to be 20,160. So those are the two types of problems, the arranging the letters and the type that has the at least or at more of something. Remember, those are ors. So hopefully that'll help you with some problems in the future when you see those.